Hello and welcome back to Calculus 1 for one very last time, right? Oh no, that's going to be on the ear. Yeah, so hello and welcome back to Calculus 1, section 5.5 for the third time. This is overview of the entire section. I said that this is going to be extremely important for your next course. Almost every problem will have you sub-lurking somewhere. So let's review the basic concepts. I mentioned on the first day that you are supposed to have a function and its derivative present, and then you can integrate. So if you have some function f that has a g of x plugged in and the g prime is present, then you can just integrate and you will get f of g of x plus c. So this capital F is the antiderivative of the lowercase f. So this is like a formula, but we understand it much better if we think about what I call function derivative pair. So integral of function and then derivative function derivative pair dx, say. So if we are observing trig, for instance, integral of x to the 8 sine x to the 9 dx, we have that u is equal to x to the 9 because the derivative x to the 8 is present. If we have integral of cosine to the 9 x times sine x dx, then our u is going to be cosine x because the derivative sine, which is negative sine, but sine x is present. I know we have to fix it a little bit and so on. If we have integral of e to the x squared dx, we need x in front, and then u is equal to x squared because x, which is a derivative, is present as well. Now if there is no x in front of e to the x, you can just cry, right? Because there's no solving that problem with the known methods that we have in the class. If you have the integral of blah over square root of blah over here, right, dx, I can't put the blah the derivative, all right? How about that? Then the u is going to be this blah, right? Because the blah derivative is present. So it doesn't really matter what you apply onto. It's a function composition. It has to be function composition, clearly. But it clearly has to be function and derivative present, and then whatever you're going to do to that function, that will remain in your sub part. Integral of some that are very difficult to detect are the ones that, because you're not used to it, maybe I should write this as a formula. So dx over x is equal to ln absolute x plus c. You know this formula from your previous life, right? And then it's a little bit harder to detect this one because you're not used to it. Say integral of x squared divided by x cubed minus 9, right? That will be that formula. Or integral of, I don't know, e to the x divided by e to the x minus 7 to the 5th power dx would be also that formula eventually. Because you have the denominator as a function. Well, actually, no. This is to the 5th. Sacrilege. No 5. There we go. Now it's much better. So, also we say the tangent x dx, right? Because you write it as sine over cosine, and then cosine is. So we did these problems already. So that's also that when you rewrite it. So all of these problems work out to be u substitution, which collapses onto ln x when you are done. So let's work out a few exercises from the textbook. One exercise says no, they're all cool. Here, 75 says negative pi to 0 of sine x divided by 2 plus cosine x dx. So this is exercise 75. So you immediately see that there are cosine and sine, so you know that those are the players. And then you can never leave the denominator to be your du, because obviously dx and du and everything else is in the numerator, because it's times dx times du. So from that point should be clear that u is equal to 2 plus cosine x, and then the derivative du is negative sine x dx. We don't have this negative, so we are going to put the negative in to make it a negative sign, because if you remember, all of this stuff is all of that stuff, which is du. So I'm going to now say negative integral, and I have a du over u. Yay, that's going to be ln of u. But we have limits, and we have to transform limits. So u1 is 2 plus cosine of negative pi, which is the denominator. Now cosine of negative pi is the same as cosine of pi, which is very good. So u1 is equal to 2 minus 1, which is 1. So the bottom limit is 1. And the u2 is 2 plus cosine of 0. Now cosine of 0 is 1, so u2 is 2 plus 1, which is 3. So we transformed our integral from x domain into u domain, and at the same time we did, oh, and I forgot to put the minus sign here, and now we have limits 1 to 3. So this is further equal to negative ln of 3, minus and minus will give me plus, ln of 1. Well, ln of 1 is 0, no one cares about that. So all I have is now ln of 1/3 as the answer. Because the negative in front of ln will go inside as the exponent of negative 1 on 3, and that will make it a 1/3. So that was the example 75. Some other examples that are maybe easier, like here problem 68 for instance, says e to the 2x, not sure if we did this one, probably, e to the 2x plus 1 dx. No limits on this one. That means you have to put plus c, otherwise it's going to be minus 1. So, well, it's the choice, plus c or minus 1, right? So we see that again we have the denominator and its derivative is in the numerator, so u equals e to the 2x plus 1, and the du is 2e to the 2x dx, and we have to put in this 2 to get everything in order. So now I have a 1/2 integral. Then, as you can see, I'm going to circle it again. There's a peanut, there's another peanut. So if you look at these two peanuts, you have the same, right? So the entire thing is replaced by du, and the denominator is u, 1/2 ln u plus c. Now we have to bring the variable back, so it's 1/2 ln of e to the 2x plus 1. plus c. And then if you want to be fancy, you will clearly just write ln of the square root of e to the 2x plus 1 plus c, because the half exponent, the half in front goes in an exponent of a half, which is the square root. Now you obviously, you know, this is full credit, you can leave it there, and this is the boss mode. So you figure the same thing goes previous example with the like 1/3 or negative ln 3. Both will obviously in the calculator give you the same value, so it doesn't matter. Fair? Nice. The next example, maybe something again with limits. Go up a little bit, there we go. Said a little bit.
How long have we been here? I saw that one coming a mile away.
I know.
You'd make a good genie. You know, they always say when you ask a genie for a wish, they give you the wish, but it always has a big downside.
I am a genie.
I think you'd be good at that.
Ooh. $64. It's gonna look diabolical, but it's actually very easy. So sine to the 5th x plus 3 sine cubed x minus sine x times cosine x dx. Yeah, I was just scanning your faces. It's not gonna be a problem. The answer is clearly 1/6 sine to the 6 plus 3/4 sine to the 4 plus minus sine squared plus c. I mean, it's obvious. Obvious. You can distribute cosine and do 3. Yes. You can distribute cosine and do 3 separate integrals, or you can actually do everything in one integral by, what's u? Sine x. And what's du? Cosine x dx, right? So if you look at this, this becomes integral of u to the 5 plus 3u cubed minus u du. You integrate each one of these, what do you get? U to the 6 over 6, you just plug in sine. U to the 4 over 4, so that's a 3/4 that I said. Right? It goes quick from that point on. I know, right? Awesome. Sine 6 plus 3/4 sine. Nice. Nice. To the 4x minus sine squared x over 2 plus c. Nice. So looks bad, but some might argue easier than the previous one. Ooh, sheesh. There is a... So I would consider this problem a bad one. I don't know. You might have different opinion. So this is 66. It says, try this one on your own for some time. X to the 3/2 plus 8, everything to the 5th times square root of x dx.
will prove spicy for final on that one, but yeah.
This has been film, right? Because we made it when I'm sorry, this is the same. I saw him a while back in the science school and helped people study and stuff.
He does have for free. He helps. He said he's going to be on the side. Because I met with him last week. And he's going to be on the other side, he said.
That's why they see the presidential
He told me
award. So the volunteer time is not paid.
if he does, he doesn't do that.
Yeah. His time is probably about 15 hours. Yeah. That's everything. Physics, engineering, obviously all over mine. He's teaching courses that he's taking. And he's doing courses that he's taking. He's taking differential equation course. And then he took the second exam, which was the longest exam which you can take actually math education. It was a power series of power transforms. And undetermined coefficients and variation of values. So those are the four concepts. Each one was a page calculation. He took 4 exams. The differential equation exam, the algebra exam, PreCalc1 exam, and Calculus2 exam. All 4, and still finished 15 minutes earlier. It's practice, you know.
How much something that is just like what, 20 minutes and more?
Yeah, some people are wired to do that. That's for him, mathematics is zero effort. He studies, obviously, but what someone will achieve in an hour, he will achieve in 10 minutes. And then there are going to be other walks in life where he is efficient and you are proficient. So we're all different in different respects, and everyone, you know, tries to compare themselves to the best and strive towards that ideal. And then they get disappointed when they don't get there. You simply have to find what you're built for, right? I mean, I have beautiful voice, but it's difficult to listen to it, so I don't sing. Very simple. Right? Everyone tells me that. Oh, I have a beautiful voice, it's just difficult to listen to it. Don't sing. I won't. That's why I just talk. I don't sing it.
It's just like this stuff I have a hard time with, but biology, I'm studying for biology, and I'm getting, you know.
It terrifies me.
You know, it's just about, you gotta find your passion. I can hear a fact, like, about anything like marine life, I won't forget it.
It's the same thing for me for chemistry. Like chemistry, I just study like one day. This I have to study. Like literally, I have a whole schedule. It's like 7 days calculus and 2 days for chem.
Yeah.
Like
everyone is different. You're going to have people that will be gods with cars, with planes, with airplanes, with engineering, and then be totally incapable to run home finances. Everyone is different.
That's how my best friend is. He has his master's in biochem. Book smart like a.
Yeah.
But when it comes to actual like day-to-day things, he's a moron. He asks me the stupidest questions.
That's so. Yeah. What is you over here?
Me?
Yes. And what's du? It's 3/2 x to the half dx, right? So we need these 3/2. If I plug in 3/2 over here, I put 2/3 in front. So we have 2/3 integral, and now I have u to the 5 du. This and this is that. Are we all staring at it? Do we all see it? So this horrible problem transformed into something simple. So we have 2/3 u to the 6 over 6 plus c. These die. So now it's 1 over 9. And we have x to the 3/2 plus 8 to the 6 plus c. And that will be the answer.
See you Monday.
Bye-bye. And let's do one more with the limits. And we are done. So one more with limits. How about problem 71? Looks fine. So 71 is 2 to 3 x over cube root of x squared minus 1 dx. I can actually put dx on in the numerator. It doesn't matter where you put dx. Kind of get used to that as well. What's the u? X squared minus 1. What's du? dx. So I need a 2, which means half in front. And I also need to change my limits of integration. So u1, we take 2 squared minus 1. You plug in the lower limit into your u substitution formula. You get 3. u2 is 3 squared minus 1. You get 8. So our new integral is 1/2 3 to 8 du over cube root of u, which is 1/2 integral 3 to 8, and now you have u to the negative 1/3 du, which gives us 1/2 u to 2/3 over 2/3. You see, I immediately did the double fraction. So I put, instead of putting over 3, I put 3 in the numerator. You can do that. And now you're computing from 3 to 8. You don't have to worry about going back to x because we switched the limits. So you have 3/4 times 8 to 2/3 minus 3 to 2/3. Now, the first one you can compute easily because cube root of 8 is 2, and then squared is 4. So this works out to be 3/4, 4 minus, and then 3 you can't really compute. So if you want the exact answer, this is where you leave it. If you want the decimals, you take the calculator and you get the decimals. So those would be the ways to compute this. If you have limits and you are using u sub, simply use the formula that you use for u sub. Every time it's different, right? So I can't write the formula for these. It's a concept that you are using equation that connects your x domain with your u domain to change your x limits into u limits, right? So this integral here is entirely in terms of x, including the limits, x equals 2, x equals 3. And this integral here is entirely in u domain, which is u and u for limits, and then variable is u and the du. So they all have to match across the board. You can't have some of one kind and some of the other kind. They all have to be the same, including the limits, have to be in the same domain. You will use this a lot in your Calculus 2 class, pretty much every integral problem for the half of the course. And then the other half of your Calculus 2 class is going to be all the limits for chapters 8 and 9. So that takes care of this one. We will eventually restart the stream for the review. So stay tuned, right?